Hello, people. I know that you are probably quite relaxed after the lunch, but I will do my best and prevent you from going to sleep. The good news is that you need to remember only 3 things after this talk. Very easy stuff, basics. But as wise men said, sometimes the easiest things are the hardest to understand correctly and holistically. By the way, my name is Andy. I'm working for fully remote company, which totally flat structure from Poland, which is SoftwareMill. And this presentation will be about Gatling, but please be patient because I need to start with some theory about performance tests. And to be precise, I want to show you why it is so hard to check performance of your application. And this will be a tip of an iceberg, and I will cover only performance of whole web systems, not some micro benchmarking of some part of the code, which is basically totally different story. So first of all good performance tests should simulate as close as possible the production environment. In terms of hardware, so the same CPU, RAM, storage. Usually production machines are quite powerful. Powerful means costly. So there is a good chance that you will not be able to buy a copy of production environment just for performance tests. On the other hand, you might face the paradox that your production is slower than test environment simply because, for example, you are using SSD drives, and on production you are forced to use some old, expensive network-attached storage. Anyone was in that kind of situation? Yeah, so it's not only me. Okay, the same software, so operation system, virtualizations, databases, and sometimes this could be hard to achieve because of some crazy licensing policy that you cannot buy more licenses or you cannot update some software because of the backward compatibility reasons, etc. Load. So how to simulate real daily application load. Obviously, if you want to test Facebook-like application, you will not launch billions of users. You need some clever way to simulate this. Usually, you are in the 99th percentile of applications with some reasonable number of users, and even then, you don't have to launch exactly the same number to get some knowledge about performance of your application. Isolation. Definitely, you don't want any interference with your performance tests. So if you are forced to use the same environment as QA testers, then I feel really sorry for you. Anyone experience this kind of situation? Yeah, more hands. Yeah, try to automate things and, for example, run performance tests during the night when nobody is using this environment. Basically, the same story everywhere. To overcome most of these problems, you need money. And if this is a blocker for you, just look for some optimal compromise. Or you can change your strategy completely and run performance tests on production. I strongly don't recommend this approach, but who knows, maybe in your case it's not such a bad idea. Just remember to delete test data when you finish. So besides dedicated infrastructure, you will need monitoring. Very good monitoring of your application, hosts, databases, messages bus. Basically, all parties must be connected to monitoring. And then logging, a lot of logging. But I would say intelligent logging. So, for example, database queries response times. Your HTTP endpoint response time, some response time to external services, stuff like that, or correlation ID, especially in case of microservice architecture. Remote access to the logger configuration so that you can change logging level dynamically without restarting the app. And you need to have those things because one of the aims of performance tests is to find potential bottlenecks. And without data, you are just another person with an opinion. That's it. And I want you to remember this as the first thing from this talk. And usually I'm dedicating this slide to my former leader because he pasted it so many times on our Slack channel that I can wake up in the middle of the night and I see this guy's face, really. I even start to use this sentence in my personal life, let's say with some difficult conversation with my wife. I'm not so sure if that was a good idea. Who would predict that she will start to use against me? Because not all my opinions are based on data. So be careful, but still, this is the first thing to remember. Another problem is, one more about this. Usually, when you're senior developer, you start to feeling something inside of you, which we could call performance intuition. So someone is asking you for help. Look, we have a problem with performance, and you're just saying, fix there or there. No, this is completely wrong. Usually after such tip, the performance will be the same. In worst case, it will be even worse. And the procedure is quite simple. First, collect the data. So monitoring, logging, profiling. Then find the bottleneck based on that data. Fix the bottleneck, but fix only one thing. Not all potential bottlenecks, not all imaginary bottlenecks, one thing only. Collect the data again and check your assumptions. Is it better? How much is it better? Maybe it is worse. And go to step number 1. Unfortunately, even if you know and you're aware of this pretty simple algorithm, the temptation to skip step number 1 or even step number 4 is so intensive that you will do it. Sooner or later, you will do it. It's like fighting with an addiction. You need to train your strong will and always make your optimizations based on some data. And if you are interested more why it is so hard to fight with your intuition, I can recommend a great book of Daniel Kahneman, Thinking Fast and Slow. And there you will get answers for questions like that. Okay, another problem is math. And so how to measure your results? And here you need to be very, very careful because there is an old saying, lies, damn lies, and statistics. And this is so true, believe me. And of course, this is the second thing to remember after this talk. Maybe not only this sentence, but the whole slide. So let's say we have a chart with response time, like on the slide. And clearly, there's something wrong with the last response. So if you use only arithmetic mean, basically, arithmetic mean is useless. It's impossible to spot a problem with the last request. Median, even more useless. Standard deviation, also useless. Standard deviation is okay only for normal distribution. When it comes to IT systems, a normal distribution is not so common. Actually, I would say it's quite rare. Another example of statistic nature could be Anscombe's quartet, which determines 4 different data sets with nearly identical simple statistical properties, yet appear completely differently when represented as a graph. So each of these data sets has the same statistical properties. Crazy, right? This shows pretty well how and that statistics will lie to you on so many different levels. So the question is, why should we use them? And my answer is percentiles. In my opinion, this is the best metrics to get the overall view of performance characteristic of your application. But be careful again and check percentiles implementation, because it could use mean and standard deviation, which of course makes them useless as well. Another example could be drop wizard metrics. Who is using drop wizard metrics? Okay, I have bad news for you. You need to get rid of them. Or you are aware of its problems. Drop wizard, let's say we have 100 samples, and drop wizard will randomly choose some subset of this set and calculate metrics based on that subset of data. So even if you have exactly the same results each time, you could get completely different percentiles each time. So this is the drop wizard metrics problem. So the next question could be, so which percentile should I be worried about? 19th, 95th, 99th? Who will vote for 90? 95th? Okay, one hand, 2, 3. 99th? More. In this case, the answer is all of them. Why? Because there is something called coordinated omission problem. And this is the third thing I want you to remember after this talk. So 10 minutes and I'm almost done. I'm good. This term was first introduced by Gil Tene. By the way, this is my performance guru. So I recommend to watch his presentations, videos. This guy really knows things, trust me. So what is this coordinated omission problem? I will try to explain it using very, very similar example. Let's say we have a test scenario, 60 seconds for the whole test, and each second we start new request, wait for the response, and then start another request. And responses are pretty fast, usually after 1 second, 1 millisecond. It doesn't matter, it's just a matter of scale. But after 31st request, we need to kill brutally our application. So system exit 0, kill -9, things like that. Why? To simulate very long GC pause or some problems with the application under heavy load. So we will not get response for this request. And usually, because there is 30 seconds left to the end of the test, usually test tools will assume that this request took 30 seconds and ended with some error. So let's check percentiles for this example. We have 31 samples and percentiles: 19, 1, 95th, 1, 99. We can see the problem, but there is something wrong here. Percentile 95th is 1. The application was dead for almost half of the test, and the 95th percentile is 1. Come on, this is smelly. Let's check how these numbers will look like in case of 10,001 sample. In this case, 99th percentile is still 1, 99.9, 1 something. Even more crazy. So maybe percentiles are not such a good metrics overall. No, in this case, the problem is with testing methodology, and usually with testing tool. Let's check how this will look like in real life scenario. In real life, we'll not wait for the response for the 31st request, but we will immediately start another request after 1 second. So 32, 33, 34, etc. This way, we have half of the samples when the application was healthy and half of the samples when the application was dead. And percentiles look completely differently. So percentile 50, number 50 is 1, which is okay because half of the test the results were great. And we can see the problem much sooner, from 70th percentile to the 99th, where there is a degradation of performance. And basically, this is coordinated omission problem. So gathering samples in the way that you are waiting with the next request, you are waiting for the response to launch another request. Any questions for that part? Okay, great. I suppose this slide, this graph shows pretty well why this gathering samples is so important. This orange line is your SLA contract. If you are able to deliver application with performance histogram under this line, you will get a lot of money. I mean, a lot of money. And you measure the performance, the red line, and you're pretty happy with the results. Unfortunately, your customer also checked the performance using different tools, different methodology, and the blue line is the real percentiles of your application. So clearly, you can say goodbye to your a lot of money contract. Fortunately, you can validate your results using very simple math. So first, you need to collect total time of the test, then the maximum time for one request, which is 30 seconds. Then, for example, we want to validate 99th percentile, which is 1 second. First, we need to calculate time in percentage for the maximum request, which is 50%, because 30 divided by 60 times 100% is obviously 50. And because max is basically percentile number 100, to calculate expected value of 99th percentile, we just need to subtract 1% from the max, which is 49%. So 99th percentile should take at least 39% of total time, which is 29 point something second. And of course, this is a fake percentile and this is a real one. Easy, right? Or you have some questions? Good. Or you can also observe the graph. Usually, real percentiles will grow with this nice blue curve, where the fake in case of fake percentiles, you can observe peak near the 99 something percentile. And if you can see this peak, usually you have a problem. You have coordinated emission problem. Because this presentation is about Gatling, I should warn you that Gatling is not fully resistant to this effect. But if you use it correctly, you can minimize this effect to some reasonable level. And the last problem with performance tests are tests themselves, in the sense that someone needs to write them, support them, and usually you have deadlines for features, not for tests. Sometimes it is not so obvious what should I test in case of performance tests. Obviously, not all corner cases, not all functionalities. I would say you need to choose most business valuable paths. So in case of, for example, e-commerce system, you will probably want to check how many users can buy something in case of Black Friday, or how fast is your search engine functionality. Okay, I think we have enough of theory. It's time to jump to Gatling. By the way, I really like good names in code and for tools as well. And Gatling, in this case, is a very good name. If you close your eyes, you can almost feel like this guy. Of course, you will shoot with requests. Okay, back to reality. So why Gatling? First of all, it's based on non-blocking asynchronous stack, so Scala Acaneti. Each virtual user interaction is represented as a separate actor, and thanks to this, you can generate huge load even from your local machine. For example, in JMeter, the only reasonable open source alternative to Gatling, of course, in my opinion, each user interaction is represented as a separate thread. And you can generate pretty decent load using JMeter as well, but it will cost you more RAM and more CPU. You can use Scala for your performance tests. How cool is that? No more JMeter XMLs. Don't get me wrong, I was using JMeter for a long time and I quite like it. Yeah, the UI is horrible, but I'm using Linux, so I don't care. But the worst thing are those XML files. Good luck with versioning it, review it, etc. And here, you can use normal programming language. Maybe in case of Scala, normal is not the best word, but still, You can versioning it, review it, reuse it, refactor it, etc. You can use Gatling even if you're a total Scala noob like me, because it's DSL, it's so easy, so readable. I will show you later. Yes, there is a recorder, but please don't use it. Of course, you can play with it, generate some basic tests. Just remember that this is generated code, and at some point, you need to refactor it. Math is good, and you will get very nice visual reports out of the box. And you could use Gatling not only for performance tests, but also for integration tests. And here is your first Gatling simulation. As you can see, you need to extend Gatling simulation class. Then there is some set configuration part and the essence. So scenario code. And please treat it as production code. You know how to make it nicer. You could, for example, start with creating your own My simulation class and hide all the configuration details there. Gatling DSL idea is to provide one big fluent builder, and test scenario should be readable almost as a normal sentences. So execute HTTP, get root, pause for 7 seconds, etc. And you just need 2 imports to make it happen. So Gatling core and HTTP. Any questions for that part? By the way, who is using Scala here? Okay, who is from JVM world? Okay, more hands. A little more complex scenario. It looks okay, but once again, very simple techniques like method extraction, and you will get much nicer code. And you can go further with that, so divide complex scenarios to a smaller one and then combine them together. And I hope that you are thinking right now, oh my god, Captain Obvious, give me a break. And yet, I want to explicitly highlight this because so many people forget about this, and then your test code looks like one big spaghetti mess with copy-paste pattern implemented everywhere. Okay, this is not important. More on DSL. So each response should be somehow validated. You can check the status like on the slide. You can check the payload using regular expression. Basically, you can check everything in the payload using regular expression. But I recommend to use built-in support for parsing JSONs, XMLs, even CSS selectors in case of HTML response. I don't want to go to explain the details here. What is worth to mention that you can save some part of the response using some token and use it later thanks to Gatling expression language. So this $sign and curly brackets. And this is especially useful in case of complex business scenarios when you need to transfer some data from request to another request. Questions? Because this is quite important. You can create some loops so that you don't have to repeat the same code over and over again. And here is basic repeat loop. There are also for each, during, as long as. Once again, details in documentation. There is also something called polling. Concept very similar to loop, but in this case, your scenario can move forward and polling will be executed in, let's say, scenario background. Conditions, so classic if else, switch, random switch, etc. Useful in case, once again, of complex business scenarios, but like in production code, too many ifs conditions, it's not such a good idea. So similar in tests, keep your tests rather easy and straightforward. TryMax, very useful functionality. Let's say you want to check money transfer from Alice to Bob, but communication between them is asynchronous, for example, via Kafka. So if you want to check if money was received right after sending money, this check could fail. simply because the message from Kafka was not consumed yet, but it will be eventually. So this check will pass probably after few retries. You could simply put a pause here instead of TryMax, but this is not a very efficient way, especially in case of performance tests. And this brings us to the scenario setup, where you can define things like how many users should be started at once, or how many users should be started using some ramp over time, or maximum duration of the tests. About starting user over time, there is really a lot of possibilities. Here you can see only some basic examples. What is important, this is highly connected to the coordinated emission problem. So instead of creating scenario and repeat it in the loop 10,000 times, you should create 10,000 virtual users for a single scenario. This way you will minimize the coordinated omission problem. Questions? Okay. You can specify global assertions for all requests. So you can, for example, expect that response time will be less than 50 milliseconds for all responses. Or you can specify failed request percentage equals 0. In case of performance tests, failed request percentage equals 0 might not be such a good idea, simply because you should expect some timeouts in case of really, really heavy application load. So I would say up to, I don't know, 2–5%, depending on the app, will be okay here. Throttling, very interesting feature, although I never use it. In this case, your scenario will reach 100 requests per second within 30-second ramp, hold it for 1 minute, then jump to 50 requests per second, and hold it for 2 hours. And this is especially useful in case of soak test, when you want to determine if your system can sustain continuous expected load. Feeders. To provide some data, unique or random data for virtual users, you will need feeders. And feeder is just a simple map which keys could be accessed thanks to, once again, Gatling expression language. And you can create feeders manually or use some built-in support for parsing JSON, CSS files, JDBC, etc. I said that configuration part is quite boring, which is true, maybe except one setting. Let's say you want to check performance of some legacy, or maybe I should say old-fashioned web system, where there is no so many JavaScript frameworks on front, and most of the HTML code is returned directly from the server. And you want to check the real user experience, so not only downloading the HTML code, but also the resources like images, CSS files, scripts, etc. And you can simulate a little bit browser behavior thanks to this setting. Launching Gatling is pretty easy, so Gatling test or test only with full class name so that you can launch only a single scenario. There is more, but showing all aspects of Gatling, it's not a purpose of this presentation. So just remember that you can create custom validators. In case of HTTP, there is you can configure SSL. There is you can simulate server send event. There is basic cookies support. You can use Gatling for testing WebSockets. I tried many different tools for testing WebSockets, and it was nightmare. Where in Gatling, the support is pretty nice. It's not so cool like in synchronous communication, so HTTP, but still, I like it the most. Yes, you can use Gatling also for testing JMS systems. Actually, the whole architecture is quite pluginable. So thanks to community plugins, you can test Cassandra, Kafka. For example, my friend from SoftwareMill recently created a plugin for zero message queue because he needs to check the performance of this queue. So this proves that the project is not dead. and community is quite active. Now I would like to share very quickly my personal experience with Gatling. So before you waste a lot of time like me and start debugging Gatling, because for sure there is some bug in Gatling, not in your beautiful test code, please turn on logging. And you can log all the requests and responses or just a failed one. And I recommend the second option for very long performance tests. It could really save you a lot of time. Reporting. Okay, this is so nice that I need to show you. So after the test, you will get very nice visual report with all the necessary performance indicators, or min, max, percentile, standard deviation. Also very nice graphs like response time distribution, response time percentiles over time, and some others. And this is generated for all actions, but you can, for example, select the slowest action for 95th percentile, which is search for, and this will be generated only for this particular action. So very useful if you want to determine which is the slowest action, slowest request, etc. Usually, your application is currently deployed on a bunch of nodes on production. And as I said, using Gatling, you can generate huge load even from a single machine. But for testing a cluster system, it simply won't be enough. So instead of this, what you really want is something like this. And yes, you can achieve this manually. You just need to start few nodes, then upload the test code to this node, start the test, gather all the results, and then generate report. And it sounds like a waste of time, because it is. You could use existing services for that, like Gatling Frontline or Fluid.io. And yes, those services are not for free, but I suppose that your time is pretty expensive as well. So I recommend to put more focus on tests themselves, not on how to launch them. And actually, that was the last idea I want to share with you. So thank you very much for your attention. Any questions? It highly depends on your application, because if you have really, really fast responses, then I suppose up to hundreds of thousands. Okay, no more question, or maybe you're too shy. If that's the case, just find me after the presentation or on the after party. Okay.